Okay, 2.4, complex numbers. Complex numbers, a plus bi, where a and b are real numbers, and then that I represents an imaginary number. You dealt with complex numbers in integrated 2. Maybe you were solving a quadratic formula, and you got something that looked like this. You were taught, you should remember, the square root of negative 16 is really 4i. The negative makes it imaginary, but the square root of 16 is 4. Still over 2, and then both of those reduced by 2. So you got an answer of negative 2 plus or minus 2i. That plus minus in the middle, those are called complex conjugates. You know, because I just showed you, when you use quadratic formula, it's always plus or minus. So if one of your solutions is a plus bi, the other solution has to be a minus bi. So it's going to be real important as we start using complex solutions that you don't forget they come in pairs. You also know from integrated 2 that the square root of negative 1 is defined as I. So when you see the square root of negative 1, you just leave it as I. So the complex cycle starts with I is just I. And then I squared is negative 1 because I squared is the same thing as square root of negative 1 squared. Squared and the square root cross out and you get negative 1. That's as high as you went integrated 2. We're going to go I cubed. I cubed is the same thing as I squared times I, which is the same thing as negative 1 times I, which is why the answer is negative I. And then I to the fourth, let's go I squared times I squared. Negative 1 times negative 1 gives you positive 1. And then you'll notice it's called this rule of 4. You'll notice it stops. Because if I did I to the fifth, I to the fourth times I, that's just 1 times I. Well, that's just I, which takes you back to the top of the cycle. So this is going to be I to the fifth. This would be I to the sixth. This would be I to the seventh. And this would repeat I to the eighth. And it would just keep repeating over and over again. That's your imaginary cycle. To help you memorize it, we've got that little thing in quotes, I1, I1, I1. I think I said that too many times. So if you were writing it down on the top of your paper to help you memorize it, I1, I1, and the middles are negative. So that can help you memorize your cycle. So it just keeps repeating. I to the first, I squared, I cubed, I to the fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. You get the idea. So it just keeps repeating. So simplifying then, the rule of 4 works out nicely because anything in the hundreds, thousands, anything bigger, hundreds and bigger, is always divisible by 4. 100 is divisible by 4, 200 is divisible by 4, 1,200 is divisible by 4. If you think about quarters, right, I can make $100, $10,000, I can make all of that in quarters. It's only the last 2 digits that we need to care about. So when you see I to the 433rd and we're asking you to simplify it, all you need is the last 2. So this turns into I to the 33rd as a problem. I don't even think this 4 should be there. You change it to I to the 33rd. Then what you do is you divide by 4 because it's the cycle of 4. So maybe you need to actually do, it's a weird division sign, do 33 divided by 4, 8, 20, 32, subtract. 1 is the remainder. So that's your new exponent. And then you look at your cycle, that just means it's I. So let's look at a quick one down here. What if I wanted you to reduce I to the 1,561st? Well, 1,500 is always going to be divisible by 4. So really, I can change this to, okay, she wants me to reduce I to the 61st. Then I can do 61 divided by 4. 4 goes into 6 one time, minus 21. 4 goes into 21 5 times, 20 minus, the remainder happens to be 1. So it's really I to the first, which means that reduces just to be I. So let's use this to do the examples at the bottom. Okay, one step at a time. So I'm going to use a different color for each one. I to the 674th. Really all I care about is I to the 74th because 600 of them are divisible by 4. When they're divisible by 4, that just means they end up being times 1, and times 1 does nothing. That's why they're able to go away. So technically I would have, let's see, what's 600 divided by 4? 150. 1 times 1 times 1 times 1, 150 times. And then whatever I have left from I to the 74th. So then you're going to do your divide by 4. Maybe you don't need to do it by hand. I'm just getting it set up for you. Then I'm going to have you do I to the 822. But 800 is divisible by 4, so I'm just left with 22. And then finally 467. 400 is divisible by 4, so I'm left with the 67. Do all those divisions and find out what your remainders are. Okay, so I did my divisions. So now I've really got I to the 74th is really I squared. The problem says plus I to the 822 is really I squared. The problem says minus. And then I to the 467 is really I cubed. So I just took all those remainders. That's where I got those numbers from. Now I use my cycle of 4 that I have to have memorized, or I can write it down. I1, negative, negative. So squared is negative 1. Problem says plus. Squared again is negative 1. Problem says minus. I cubed is the third one. Negative I. Finally, do the little bit of combining like terms. Negative 1 plus negative 1. Negative, negative plus I. This is the simplified version of the question they gave me. Okay, another rule about complex numbers. You can't have i's in the denominators. So, if I haven't made it clear yet, no exponents on your i's. That's why we have the cycle of 4 to get those down to either 1's or i's. Also, no complex, no imaginary, no i's in the denominator. So to fix it, we're going to multiply top and bottom by the conjugate. Conjugate of 3 plus 5i is 3 minus 5i. Top and bottom, because technically I'm just multiplying by 1. Go ahead and distribute on top. And then see what happens on the bottom. On the bottom, you're really doing a binomial times a binomial, so you might want to use an area diagram to help yourself out. 3 plus 5i, 3 minus 5i. This is where we're going to find out why did she multiply by the conjugate. Negative 5i times 5i is negative 25i squared. So notice you have positive 15i and negative 15i. Those go away. So I'm left with 9 and negative 25i squared. But no exponents are allowed on your i's, right? Look at your cycle of I. What is I squared? This is really negative 25 times negative 1, which is really just positive 25. So really I just have 9 and 25. 9 and 25 makes 34. So anytime you multiply conjugates, you're always going to get a constant. So it will get rid of all the imaginary numbers. And if you love a formula, if this is a minus bi times a plus bi, it just ends up being a squared plus b squared. But you can do your area diagram to help you find that each time. Also though, number 2, everything's even. Everything's divisible by 2. Factor out a 2. 2 goes into 34 17 times. Negative 6 plus 10i over 17 is a much better answer. Okay, number 3. When you see negatives under the square root, you know you should take out that as an I. So I have I root 18 times I root 20 times root 2. Now you're welcome to try to do 18 times 20 times 2, but I prefer to make things smaller. So 18 is root 9 times root 2. Root 18 is root 9 times root 2. Square root of 9 is 3, so this is 3i root 2. Square root of 20 is root 4 times root 5. So this is times 2i root 5, and then times root 2. Multiply your whole numbers, multiply your i's, multiply your roots. Now I'm back to 20, so I can do that one again. This is root 4 times root 5. I could have done it earlier also. So I have 6 times, what's I squared? Negative 1 times square root of 4 is 2 times root 5. Finally, multiply it all together. Negative 12 root 5. Okay, imaginary numbers, complex numbers can also be graphed. They get graphed on a complex plane. So when you set up your axes, you need to label them because it's not just a normal plane. The x-axis is the real axis and the y is the imaginary. And if they're written in the form a plus bi, the a value is basically like your x, and the coefficient, the b value, is basically like your y. So this is kind of like the point 1, negative 1. There's the imaginary point. So see if you can plot this imaginary, complex I should say, number. Label your axes. Negative 2 on the real, positive 3 on the imaginary. Okay, one more slide. Just basic simplifying. So adding, subtracting for number 1, multiplying for number 2. See if you can do those two on your own. Pause your video. So the one thing to be super careful of for number 1 is when you subtract, make sure you distribute your subtraction sign. So if I was going to show extra work, this is 2 plus 3i minus 5, but then it turns into plus 2i. Then you just combine like terms. Negative 3 plus 5i. Number 2, multiplying. I recommend using an area diagram. You're just multiplying two binomials together. 3 plus I root 2. Two I root 3. Fill in your area diagram. I times I is I squared. Root 3 times root 2 is root 6. But remember, you're not allowed to have exponents on your i's. I squared is really negative 1 times root 6. So this box is negative root 6. So then combining any like terms we have, which we don't because we have a 6 by itself, and then we have plus 3i root 3, that doesn't match 2i root 2. You can't add them if the roots don't match. And then minus root 6. This is as simple as it gets. Last one, number 3. You can only multiply 2 at a time, so it really doesn't matter. Maybe take these two, make your area diagram, multiply it out and simplify it. And then when you have that, you will multiply it by the remaining binomial. So let's set up the first one. Take a second and multiply those together, and then when you unpause your video, I'll have my first step done. When you multiplied those together, you should have gotten 3 plus I. Then, that's just the first two. Now I need to bring down the third trinomial, make another area diagram, and see what you get after you simplify that. I'm not going to show my work for that one, so pause yours, make your area diagram, and then see if it matches my final solution. Hopefully you got negative 7 minus 9i for your final solution. So this is just a little bit of a review and some new information about complex numbers.